Okay, hello. We are going to be doing something different today, which is looking at my personal AI rig. So, yeah, not our coding videos, but I just wanted to make something different that I feel like maybe you guys would like to know, as well as I think that right now it's kind of meta, and a lot of people are looking for or looking to build their own AI rig, right? To do run their own LLM models, or to do their own diffusion models, right? Generating AI art, for example. So this is my rig as of now, which I want to first put out is very not well done, in the sense that I didn't build this with the thought of creating AI. This is just a buildup of all old parts I have after upgrading my current computer, and just stuff I picked up for really cheap. So let's get started. So part one, the hardware in my AI rig. So the CPU is rocking a Ryzen 7 2700X, and the motherboard to put this together is the ASRock Vitality B450M gaming ITX motherboard. It's a really small motherboard, big ITX, so it only has one PCI lane, which will only support one graphics card, as well as only two DIMM slots for the RAM. So as a result, I'm limited to realistically about 16 gigabytes of 3200 mega transfers per second RAM. And my 2070. So the 2070 is a graphics card I just have lying around because I recently upgraded my main computer to a 3090. And so I had to take that 2070 and I put it in that computer instead. But originally, before I bought my 3090, that was rocking a 1060 6 gigabytes, which was also sufficient. Although I doubt it would be able to do the diffusion that I'm able to do now. So yeah. Would I buy this? No. I think you could get if you are very dedicated to making a AI rig just for artificial intelligence, then there are much better options out there, as well as much better videos going over that process and picking sufficient parts. So here are my hardware suggestions. Now, I'm no expert by any means, and I don't want to pretend to be one. But this is just based on my knowledge on kind of using AI and the type of information that I've been hearing around. When you want a NVIDIA card with VRAM about 12 and greater, right? So that's going to include the current 30 and 40 series, and then also the 50 series will be coming out. However, from what I heard, the 50 series are going to be outrageously expensive. So you might as well stick to a 30 or 40 series. And the 30 and 40 series, they all have their own cards, which have about in the range of 12 to 16 gigabytes of VRAM for a reasonable amount of price. And in that case, I would say go for it. If you want more VRAM, you can get a Tesla. However, I would note that Tesla series GPUs are much older. They are a much older generation. They're on par with about 20 series cards, 10 to 20 series cards. So it's an older generation that should still be supported by current gen software, and they normally have more VRAM than a GPU, a RTX card for that same price point. However, they aren't for gaming. Their clock speeds are lower, their boost speeds are lower, and so in a sense, your performance of the models, although yes, you can run larger models in that VRAM space, however, as a result, you are going to lose some on that performance because of just how old these cards are, as well as not to mention that these cards typically don't come with their own blower. You also have to purchase a blower and a mount for them. So again, I would still go for those gaming cards. Okay, so where was I? Sorry about that. If I were you, I wouldn't get a AMD card or a Intel Arc card, as although those are much cheaper options than NVIDIA. Right now, NVIDIA kind of have a monopoly and also have the most expensive cards. And yes, AMD have larger VRAM offerings for cheaper prices. However, generally speaking, a lot of programs are not designed to run on AMD cards or Intel cards because their tool chains and their toolkits are not mature enough, not ripe enough. NVIDIA was smart when they first introduced CUDA, which is their programming interface, in order to actually directly program on the GPU as if it were kind of like a CPU. Now I'm oversimplifying a bit. But because of that initial investment by NVIDIA, basically all AI libraries, as well as a lot of models, only really work on NVIDIA cards. Otherwise, you're going to have to be doing a lot of different hacking solutions to get that working on other cards. And in terms of like Ollama and whatnot, they actually are pretty well done, as they can run on a variety of hardware, including Apple's silicon Intel's M series silicon, and they actually run their LLM models very well on there. However, again, in order to just have a more flexible arrangement, I would just go for NVIDIA. So yeah, enough with that rant. All right, part 2, OS and tools. So this is what I have on my system. So in terms of the operating system, I'm running Fedora Server 41. The reason why I chose Fedora Server compared to Ubuntu Server is because, honestly, fuck Ubuntu and fuck Canonical. They are commercializing what traditionally isn't thought to be commercialized, as well as they're selling their stupid subscription, whatever bullshit, Ubuntu Pro. And I simply don't like it, and I do not like snaps. However, I would like to note that a lot of AI and training and stuff done on the enterprise level are going to be Ubuntu, at least for AI, because AI and Ubuntu work really well together, as well as the tooling built for it. However, it's because this is Linux, anything is really capable on any type of distribution. So I personally chose Fedora Server 41 because it comes pre-bundled with Cockpit, which I will talk about next, as well as I generally like Fedora and they don't try to sell me stuff. I run Fedora on my laptops and on my gaming computer as well. So part 2 is Cockpit. So Cockpit is a visual interface for the server, so you can manage stuff like the network interfaces, storage, you can spin up virtual machines, etc, etc. But it's just generally nice to have. It's not a necessity, as you actually most of the software won't be happening in Cockpit. Again, it's all going to be in the terminal. So if you really want to get started, I would suggest learning a bit about Linux first and how to operate a Linux machine and its file system and whatnot, and kind of understand a bit about the commands. A command I would really emphasize on using is PowerTop. PowerTop helps to get more efficient and optimize rigs, so your rigs can draw less power when idle, because ideally these kinds of rigs are not ones you're actively going to be on, but you are connecting to from other computers and whatnot. At least that's how I use it. And then this one right here, Samir Haired Web. I use it personally. It's not actually necessarily a requirement. It just allows me to wake up my gaming computer outside of my home network, or outside of having to actually physically touch it. I'm able to send what's called a magic packet or a wake on LAN packet, which automatically turns on the computer. So as a result, I don't have to keep my computer constantly running, and when I'm away from home or not physically within reach to press that button, I can still spin up the server whenever I need the AI software I have on there. As well as Docker. Docker, completely important. I would say that's just a general programming thing, not even specifically for AI. But Docker is going to be your best friend, and Docker is basically one of the best ways to run any AI software, because it provisions and creates a virtual environment, what we call containers, that have all the dependencies at the perfect version, and basically it doesn't allow for compatibility issues, or at least it limits those compatibility issues that would happen if you try to rebuild and replicate an environment perfectly to what the project offer is. So Docker is a really important software to have, and that just requires virtualization on your CPU. So if you pick a CPU, you want to have a CPU that has Intel. If it's Intel, it's going to be VTD, and then also you have AMD's equivalent of virtualization you can find in your BIOS settings. So part 3, AI tools. So this is actually what the AI stuff I work. So here we're actually getting into the meat. So in terms of LLM, I run Openwebui, which is a web interface. Basically, it looks like ChatGPT's interface, but allows you to use your own models instead of having to use ChatGPT for your LLM conversations. It's a really nice interface, really sleek, really clean, as well as it's very flexible. It allows you to use multiple different kinds of models. And how it works is it works by connecting to Ollama. So Ollama is actually a command line interface, a utility where you can actually run models in the command line. However, you do not get all that syntactical sugar that AI typically generates. For example, like bold, headers, tables, etc., etc. However, Openwebui is able to render those properly the same way that the AI intended to render it. So, in a sense, those two go hand in hand, although it would be noted that Ollama can be used on its own as a terminal-based application. However, that's not necessarily the most ideal. But Ollama is what's actually serving the AI backend that Openwebui is going to function with. Without Ollama, then Openwebui won't do anything. And then for actual programming, if you're a programmer like me, you can use Continue, which is it's just like Microsoft Copilot, which is their programming AI, which works hand in hand with your software development as to allow you to basically do programming with AI, and it uses Ollama in the backend. So again, we're able to use our own private local models instead of having to rely on and pay for models to use by those big companies out there. All right, here are the models that I use. These are all available on Ollama's library. So I use Llama 3.23b. It's a very good general purpose model, and it's also low resources. So the 3B and 7Bs that you see represent the parameter count. And generally speaking, the higher the parameter count, the more accurate the model is going to be, but the more resources it requires. It requires more VRAM and more time, so it has a lower token generation per second. But Llama 3.2, due to Llama's, basically due to Facebook and /Meta's ingenuity, they've created a model that's very good on benchmarks, very comparable to those 7B parameters while only utilizing 3 billion parameters. So it's a very versatile model. Now, these two, Qwen 2.5 Coder and Qwen 2.5 Math, these are two AI models that were trained on specific data sets. So the Coder was trained on specifically just code, and the Math was just trained on specifically Math. So these two have very specific functions, so it won't be able to answer or be more general compared to Llama 3.2, but they excel at accuracy and precision for what they're designed to do. So that's going to be Qwen 2.5 Coder, which is going to be really good for coding, and which I use with Continue as my coding backend. And Qwen 2.5 Math, which I use for math whenever I have math problems that I need help with and I don't have availability to a teacher. So what should be noted, however, is that all of the models on Ollama, to my knowledge, are quantized, which basically says, and I'll explain it in the next slide what quantizing means, but it allows these large models, which would realistically not be able to run on any consumer device, to run on a consumer device, and they do so with this. So what is quantization? So basically what it does is it reduces the amount of space a parameter occupies in memory. And it maps those, it does that by mapping wider range of parameter weights into smaller range of numbers. So we can look here on the right side. So for example, this is I believe, floating point 16 number, which shows from what range, so this number to this range, this number, right? And then, these are actually parameters. These are the parameter range. And what basically happens is that these parameters become mapped to a smaller range of numbers. So you can see down here how much memory that these different data types use. So floating point 32 means that it requires 32 bits. Floating point 16 requires 16 bits. Floating point 8 requires 8 bits. And int 8 requires 8 bits. So the difference, so this is how they represent floating point numbers right here. And how it does is you have the fraction, the exponent, and the sign. So the sign determines whether the number is positive or negative. The exponent is to what power. So it basically works like scientific notation, where we take a number and then multiply it by 10 to the power of something to get a more precise number. However, as a result, by reducing the precision, the bit precision of these numbers, you lose a bit of the precision in the number. So for example, in this one, 0.15625, if we were to reduce it, say, to an example, floating point 16, we might only get 0.156, right? We lose two of those numbers, but as a result, we reduce half of our memory usage. And so for Ollama models that you run Q4, what happens is that, for example, these model weights, so this is the maximum of our model weight and the minimum in our model weight, these get mapped to the minimum value that can be represented by typically int 8 versus and the maximum in int 8, which is correlated and connected to our maximum parameter value. So as a result, no longer do we need to store these weights in floating point numbers, right, because they have the point in them, but no, they can be then stored in integer format, which requires a lot less memory, and as a result can run on most consumer level hardware, but we lose a little bit of that precision. So you can see here, so the precision and accuracy decreases while the model performance increases and the space requirements decrease. So that, in a sense, it's kind of a trade-off, right? You want to see how much can quantize it with it kind of still retaining similar performance to as if it was unquantized. However, you do not want to quantize it so much that you basically ruin the model's performance. And then basically most models on Ollama use the Q4KM, which reduces a 32-bit floating point number into an 8-bit integer. So part 4, Openwebui. So here's what you're going to see once you set up Openwebui, and you can set it up using the GitHub. I will link that in the description. And so here you can just sign up. Don't worry that this is just locally stored, and it does not actually communicate to any outside servers So here is the general loadout. So here you can start your prompt, start a chat with your first prompt. And then right here, you're going to see your model selection. So here you can change what model you want. And then on the left side here, you are going to see your account in the bottom left, as well as your previous chat history. So if we were to focus more on this shows what models you have. Typically, or obviously when you start, you're not going to have any models downloaded because Ollama needs to download the models, which require a large amount of space, about maybe, I would say about 4 to 10 gigabytes per model. That's a really good range, I would say. And then under here, you can see all your different models. So for example, my Llama 2, my Llama 3.2, my QuantMath, and my QuantCoder. But you can also just directly pull if you go in the search bar right here and then type in the name and the tag. So the name would be this and the tag would be its parameter count. You can also download it from the WebGUI UI. So what should be noted when you set up Ollama, and this is an issue I ran into before when I was trying to set it up, is you need to make sure and ensure that your environment variable is for the service, right? Ollama is a background service. That you set the Ollama host to 0.0.0.0. Because by default, Ollama only maps to 127.0.0.0.1, which is also known as localhost, meaning only the physical computer which runs the service can access the network resources. However, we don't want that because typically we're going to have this running somewhere else on a different computer. So you want the environment variable to be 0.0.0, which says broadcast. So it's going to broadcast to the whole network the service. Now, another very important thing is to allow it in your firewall. Some don't come with a firewall by default, but Fedora Server for sure comes with theirs. And I ran into a lot of problems trying to set this up before, not realizing that I actually have to allow the port in the firewall. So you can see here I'm allowing a port for Ollama, which is 11434, and I just allow it. So basically it can exit and enter the computer, whatever. And then here in the admin settings and the models, you can manage where that connection endpoint is. It's referring to localhost because I have this running in a Docker container, and localhost is mapped to this IP address of this Ollama service. So that was a lot. Now I want to talk about one of my most favorite, because I think it's really fun, is ComfyUI. So ComfyUI is basically a very high-level usage of creating diffusion models, creating diffusion pipelines. And basically, diffusion pipelines allow you to, for example, here, this is, I just take it from the GitHub link right here, but you take a model, you can load it with a positive and negative prompt, and then change parameters of that model to then create an image. It's very simple to use, it's very intuitive, and there are much better tutorials on how to use it, because I won't be diving into how to use it, because that would be very specific depending on what you want to do, and I just think other people can do much better explaining than I can. But ComfyUI is a really well and popular program that's being used for diffusion models. I forgot why I put this here. Okay, part 6, some numbers. So this is me looking into actually some benchmarks and some power utilization, because that's important. It's not as important in America where electricity is cheap, but in other countries it might be very important that we have computers that run at very low electrical rates. So here's my system. At idle, it draws about 50 watts, which isn't efficient at all. That's pretty high. To put that in scale, I run a Raspberry Pi, which draws about maybe 1 or 2 watts at idle, that I run Pi-hole on, as well as I have this Lenovo mini computer running always, that runs as my VPN server and my coding server, and that draws about 10 watts, 5 to 10 watts on average at idle. And once this reaches about 100% utilization, so for example, when I'm downloading a deep gen model, diffusing an image, it draws about 150 to 200 watts at its maximum. Now this isn't good, which is why I suggest to enable wake up LAN on these computers so they can be turned on when necessary and shut off whenever not needed. Because as a result, it's just going to be burning electricity for no reason at all. For Llama 3.23b on the 2070, it goes to about 100 tokens per second, which is really fast, I must say. Really fast. Because honestly, on average, you need about 20 to 30 tokens per second for it to be considered usable. You want it to be about matching the rate in which you can read text. So 100 tokens per second is extremely fast. And as you see, it's because of the smaller model, and again, the 2070 being such a performant graphic card, graphics card. But for example, also looking at Llama 2 on Sensor 7B, so these two are larger models at 7 billion, and you can see that they average about the same, about 60 tokens per second, which is still, again, very usable. That's a very high token per second rate compared to what would be, typically acceptable. Like, for example, ChatGPT, though they don't say, their free model, it looks to be about maybe 20 to 30 tokens per second. So yeah, you can get comparable performance to ChatGPT with much better tokens per second. And then for ComfyUI, rendering a 1024 by 1024 image on about like a 7 gigabyte image model, it takes about 20 seconds per generation, which is low. It's not as fast as if it were to run on my 3090, which can do it in about like 2 seconds, but still very fast. And very acceptable, right? This range, like, it depends on what you're going to use it for, obviously, but if you're just using it to generate images from now and then, a 20-second generation is very fast. Okay, and this is the end of this very long video that I actually took much longer to set up. Like, this slide took me forever, so yeah. Have a good one. Yeah, the next video will probably be on the Go series because that's obviously going to have to be worked on. All right, have a good one.